And we got 3 minutes. Looks like the video stayed in check. We're still postage time 103.059 plus 0.067. So the key thing with decimals is lining up that decimal point. So we'll make a stack. 5. Oh, there's a 0 there. 0, 5, 9. Ugh, that's so ugly, Mr. Daly. Plus 0.067. Right. So now we've got our decimal points lined up. So that's a 0, by the way. Ugly 0. 9 and 7 makes 6. Carry 1 over. Well, 16. Carry the 1 up. 1 and 5 is 6, plus 6 is 12. So 2 goes down there. Carry 1 over. 1, 0, and 0 is 1. And then we carry that over. And then we've actually got nothing left of this number, so it's just going to be 103. Looks like Josh got the same answer. That's great. Oh, we've stopped our stream. Sorry, guys. I thought there might be a few issues with this. Yeah. Alright, let's get on to the next one before it freezes again. So, 3 minus 7, we can't do it, so we need to borrow. So we'll borrow 1 from there. 13 minus 7 is 6. 0 minus 9, we can't do it, so we need to borrow from this 2. So it's now a 1. Make that a 10. 10 minus 9 is 1. 1 minus 3, can't do it, we've got to borrow. Make that a 2. Drag 1 over, so that's an 11 now. 11 minus 3 is 8. 2 minus 1 is 1. 18.16. That was a bit better. Cam stayed alive. Alright, decimals. So, what we want to do is think about how we can break up these decimals into, so if we were going to pull some numbers out, we put a 0.01 underneath and then multiplied by 98. And then on this one, we've got a 0.01 underneath and then multiplied by 76. And that's a double shift. That's a double shift. So we're going to get a quadruple shift. So our final answer is going to get moved 4 times. 4 moves. Alright. So instead of writing this like this, I'm just going to swing this 76 underneath. So we can just do an algorithm. Alright. 6 times 8, 48. Carry the 4 over. 6 times 9, 54. Plus 4 is 58. Another 8, 58. Alright. 7 times 8. Well, we need to put a 0 placeholder here first. 7 times 8 is 56. We want to carry the 5 over here. That's here. 7 times 9 is 63, plus 5 is 68. Now we add those together, we're going to get 8. 8 and 6 is 14, carry 1 over. 6 and 8 is 14, carry 1 over. 1 is 7. So this is our number, and then remember our decimal point was here, and we're going to move it 4 times. So 1, 2, 3, 4, it's going to sit in there. So our final answer is 0.7448. Alright. The division question. Let's go. So, when we do division, what we want to do is line up, make it into a fraction, because fractions are division. Division, fraction, same thing. But when you put it as a fraction, it makes it easier to move the decimal place along. Well, you can still do it in this form, but it's just a little bit easier to see what you want to do. So we want to make this number that's divided a nice even whole number. So if we put the decimal point there, we've moved it 1 back, and now we'd be dividing by 5 instead of 0.5, 0.5. But when we do that, we need to move this decimal place back. And you can think of this as like timesing by 10 on the top and bottom. So when you times a number by 10, basically it's just shifting the decimal place. So our final answer is 426.05 divided by 5. This will get you the same answer as the answer above. So once we've got it like this, we can put it into an algorithm bus stop form. So we're dividing by 5, and that number is 426.05. So 5 goes into 4, doesn't go. 5 goes into 42. 8 times remainder 2, because 5 times 8 is 40. Remainder 2. So 5 goes into 26 5 times. 5 times 5 is 25. So remainder 1. 5 goes into 10 2 times. 5 goes into 5 1 time. So final answer is 85.21. Alright. There's a little bit of lag. I think I'm running so many things at once. Okay. Estimating. And rounding. So, we're going to go through the estimating first. We haven't done too much of this, but the idea with estimating is that you want to round it to basically what's called one significant figure. So we're basically rounding that one place up or down depending on the number before it. So that 28.9, the closest number to it, that's nice, and a nice number is 30. And for 605, it's going to be 600. So we're just focusing on that first digit on the left, but it still has the same sort of scale. So 605 and 600 are relatively close together, and 28.9 and 30 are relatively close together. But these two numbers are nice numbers that you can do in your head, because we have 3 and 6, which is just our times tables, and then we're just going to tag those 3 zeros on the end. So 3 times 6 makes 18, and then we've got 1, 2, 3 zeros. So this is your estimate. So the 18 comes from 3 times 6. What I might also do is, have I got a calculator somewhere? There it is. So I'll just also show you, this is quite cool that I can get this both on the same screen. If we did the actual answer times 605.2, see how we get our answers is in the same sort of ballpark. We'll say it's only really 510 difference, and out of 18,000, it's not actually that significant. So this is the actual, and this is the estimate. Alright, let's do this one. 72.3. So 70, we're going to round it to, well, 72.3, we'll round to 70. 9,800. So for this one, we would generally round that 9 up. So you got to be careful with 9s, because they are going to make it in order. It's going to round up to a 10. So really, 9,805 is fairly close to 10,000. So 70 times 10,000 is just like 7 times 1, and then you tag on your zeros. You've got 5 zeros. 2, 3, 4, 5, and then put the comma in last. 70,000, this is your estimate, and then let's do the actual. So 72.3 times 9,805. So 708,901.5. This was our actual. But whenever you're asked to estimate, this is the correct answer. And if you, in the final year exam, you're likely to get a question like this, and if you put the actual answer, that's just showing that you don't understand what estimating is. So you wouldn't get that right if you put that answer, but you would if you put this answer. Hope that makes sense. So be wary of that. Alright. 599 is similar to 600, and 0.098, we want this digit to change, so we look at the one before it. It's going to round up our 9, which is then going to round up to the next digit over. So this, oh, I think we've frozen. I'll just start from the start again with that. Just a moment. How long ago did it freeze? What question? Halfway through 2. Okay, so all that I was talking about with question 2 was that the estimate is, well, oh man, I wish this would work flawlessly. So the estimate is just 7 times 1, and then tagging on your zeros, and then the actual is not the, would not get you the point in the test, because they're testing for whether you know how to estimate. Alright, so for number 3, 599 rounds to 600, because we're just rounding, we would round up. 0.098 you've got to be careful with, because the 8's going to round up this 9, which is then going to get rounded up to 0.1. So there's no longer a 0 in that decimal place. And now we know that 0.1s just move our decimal point 1 over. So our final answer is 60. So this is our estimate. And our actual answer will be, you know what, that might help. 599 times 0.098. So 58.702, that's our actual answer. But you can see that these numbers again are relatively similar in magnitude. And that's the whole point of estimating. You can get fairly close to your answer by rounding things off and just using basic times tables. So you're just using your knowledge of your regular times tables and then tacking zeros onto the end of your answer. Pretty simple, really. Alright, but actually used a lot in real life estimating. Okay, rounding. Let's try and get that more central. So, rounding, there's lots of different ways. Well, there's 2 ways you can round. There's decimal places, DP, and then there's significant figures, SF. So what we were doing in estimating is we were actually doing one significant figure. So I'll just give you a little tutorial in doing 4 significant figures later on. It's not too much to grasp. Alright, so with 1 decimal place, we want to look at the first decimal place. That number is going to be the last place in our final answer. So we want to round up or just cut off the rest of the number. So the 5 is going to round up to 3. So our final answer is 27.4 for 1 decimal place. 3 decimal places, we would look at the 3rd decimal place, and then the number below it is a 2 this time. So that will not round up. So basically you just cut off the rest of the number there. So we've got 27.359. Alright, 4 decimal place, we would be looking at our 4th decimal place, which is a 2, and the number before it is a 6, so that will round it up. So that is 27.3593. Stream's still going, that's good. 4 significant figures. So if it was 1, then we'd round up to 30, right? So with 4, you've got to you still come from the left side. I might just do this in a red pen so it's different. So that would be 2 significant figures, 3 significant figures, 4 significant figures. So starting from the left, the digits get more significant. So the value of the 2 is 20, and then the value of the next one over is 7. So the 2 has more values, so it's more significant. So that's the second most significant figure. And then the 3, that's like that 30 cents. So $7 worth versus 30 cents. This is even less significance, right? And then you could think of this as 5 cents. So 30 cents is more significant than 5 cents. So we want our number to be just 4 digits, basically. So we want to look at this one before the 4th digit, and it will round it up. So 4 significant figures would be 27.36. I hope that made sense. But don't worry if it didn't. At year 9, we really just want you to be able to do decimal places. But I just wanted to just get that in the back of your mind, because you will be using it in year 10 and so on. And it's not really too hard to understand if you understand how to round with decimal places. Okay. To finish this up, we're going to do some algebra revision. So I'll just get that on the screen. I wonder if maybe it's better to zoom in a bit more. There we go. That's probably much better. Sorry, Josh, I'm not actually sure what you're referring to then, but I'll try and cover it at the end of the chat. We've got to move on. Alright. So, algebra. Let's do it. So we have 2x plus 9 equals 39. First thing we need to do, we need to deal to this plus 9. So, to do that, we need to subtract 9 from both sides. That would leave us, so that plus 9 and negative 9 cancel out. We will just be left with 2x equals 39 minus 9 is 30. Alright, now we want to know what 1x is. We know what 2x is, so 2 times x is 30. So if we do 2 times x divided by 2, and then we divide by 2 on the other side, then we will get x equals 15. So that's our final answer. Number 2, we want to get rid of 23. So we will add 23 to both sides. Oh, I should have used red pen. Oh well. Which leaves us with 9x equals 54. 9 times x is 54, so 9 times x divided by 9 equals 54 divided by 9. Remember that these 9's cancel out. We're just left with x equals 54 divided by 9 is 6. Alright, brackets. So when you've got brackets involved, the first thing that you need to do is to expand from here to here. We expanded. 3 times x is 3x, 3 times 12 is 36, and that equals 63. So we wanted to cancel out this positive 36. We subtract 36 from both sides. 63 minus 36 is 27. Well, those are gone, so you're just left with your 3x. 3x equals 27. The next thing to do is to divide by 3. Both sides. 27 divided by 3 is 9. 3x divided by 3 is x. Okay, number 4. Expand the bracket. 4 times 5x makes 20. 4 times negative 32 makes 128. And then 12 is 12. To get rid of this negative 128, we need to add 128. 12 and 128 is 140. Those end up cancelling, so you're just left with 20x. 20x equals 140. 20 divided by 20 will cancel those out, and you're just left with x. 140 divided by 20 gets you to 7, and you can do this 0 cancelling on the top. Alright, that concludes the questions I want to get through.